Hey folks, okay, so this is a mathematical way of doing our Lewis structures. And you know yesterday, no, that would have been Monday, when we worked on SO3, and I told you that we would do a step-by-step process on how to figure out the Lewis structure, which ends up being this, double bonded to the O, bonded to the O, bonded to the O, and we were a little bit confused about how all those bonds came. I'm going to show you step by step on how to do this for all questions, and then there will be secondary and like third videos that do it with polyatomic ions. Okay, so the math that we're about to do in these step-by-step processes only work for covalent molecules or molecular bonds that obey the stable octet rule. Okay, and in grade 11, that's everything we're going to do. Okay, so we're going to consider this. We're going to redo SO3. And we're going to show the math that goes with that. Your first step, okay? Every time you're doing this, you want to total up all of the valence electrons if the atoms had a stable octet. So what that means is if we had, for SO3, if we had a stable octet, there'd be 8 electrons around the sulfur, and then there would be 8 times 3 electrons around the oxygen. Okay, so that's a total of 4 multiplied by 8 electrons, which gives you 32 electrons. So that's if every atom had a full octet. The next step is to consider the valence, the total number of valence electrons in your neutral atoms, so just as they appear on the periodic table. So that's their group number on the periodic table. So sulfur and oxygen on the periodic table, sulfur has 6 valence electrons, and sulfur has 6 valence electrons, and there's 3 of them. So that, in this case, would be 4 atoms, or 4 times 6 valence electrons, which gives us a total of 24 valence electrons. If we're doing polyatomic ions, which is what we're going to be doing today, okay, this step is very important. For the example of SO3, it doesn't have an effect, but you will see when we do the polyatomic ions that it does. So if you're working with polyatomic ions, you either have to add in or subtract, and I'm actually going to put that into a separate line. So add in negative for polyatomic ions, and I moved the whole page, or you're going to subtract the positive charge. Okay, so because we're not dealing with a polyatomic ion, our number of electrons that are bonding, that are found in the neutral would be 24 electrons still. We don't have a charge. everything that we learned on Monday didn't have a charge except for, no, nothing had a charge. The ionic created 2 ions with charges, but none of them ended up with an overall charge. So don't change. Okay. Now you're going to calculate how many bonds you're going to get. You do this by taking your stable electron number, and that's from your total, and subtracting the neutral electron number. And if you're doing polyatomic ions, that's your with charge. That's for today's lesson. So this is from number 1, and this is from number 3. And when you do that subtraction, so for us, it's 32 electrons minus 24 electrons, gives us 8 electrons. These are going to be 8 bonding electrons. That means there are going to be 8 electrons that create bonds between the atoms. That's not all the electrons that are in the octet, but these are the ones that will be bonding. I'm going to say between atoms. So how many bonds is this? If it's 8 electrons, and we divide it by 2 because there's 2 electrons in each bond, that's 4 bonds are going to happen. Okay? The last thing you need to consider is, what about all the other electrons? And those are going to be created in lone pairs. So you find out your total number of electrons that would be in lone pairs by taking your total neutral what did I write up here? Neutral electron total, total neutral electrons, sorry, I've got that backwards now, minus your bonding electrons. So for us, that's 24 electrons minus the 8 electrons that are going to be bonding. And that leaves us with 16 electrons that will be situated in lone pairs. So we know that there are 8 bonding electrons, so 4 bonds, 16 lone pair electrons, so that's 8 sets of lone pairs. SO3. Because there's 1 sulfur and 3 oxygen, we're going to situate sulfur in the middle and surround it by oxygen. Okay? You always start with your bonds and worry about your electron pairs later. So there are going to be 4 bonds between sulfur and oxygen. Okay, I'm going to fill in, there's 1, 2, 3, and because there's no other option for sulfur to bond to, a double bond is going to be created somewhere. Ooh. Okay, so 1, 2, 3, 4. So sulfur now has 8 electrons around it, and we've got to fill in our lone electron pairs. So 8 sets of lone electrons. So when we're doing this, you always start with your atoms that are on the outer parts of the molecule. So this is on the outer part. This is on the outer part. This is on the outer part. This is inner. And only when you filled up your outer atoms do you go back to your inner atoms. That's more of a grade 12 thing. Okay, but that's the rule. So I'm going to start over on this atom over here and give it 1, 2, 1, 2. I can get rid of all the green because it messes up my electrons. 1, 2. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And the reason I didn't start on the oxygen that was in the double bond is because there are 1, 2, 3, 4 electrons acting in that bond. So there's 4, 5, 6, 7, 8 now around that atom. Okay, that's how you would create it. So we're going to do it today with polyatomic ions. Now I'm going to stop the video, but continue the note.